Hello everyone, my name is Stefan. I'm going to talk in this video about complex number. What is complex number, what is the standard form, and how you can add them, subtract, multiply and simplify. Hopefully we'll learn everything about complex number in this video. And let's start. First, let's talk about the real numbers. We know the real numbers, for example, are always positive. The square of our real numbers is always positive. So if you sometimes we have an equation, for example, like this one here, and it will be very hard. It will be actually has no solution on the group R. So let's try to solve it and see what is going to give us. So we have x squared plus 1 is equal to 0. Therefore is x squared is equal to minus 1. Therefore as x is equal plus minus square root of minus 1, and this has, so the solution of this equation is not exists on R. So in this case what we did, we come with something called imaginary number is, and they call it I, imaginary number I, and in which I square is equal minus 1. So let's try to solve the equation this time, but in complex numbers. So what is going to give us this is here, this equation is give us x squared is equal plus minus square root of minus 1, and is going to give us plus minus I. So this is the solution for this equation in complex number. That's the solution in complex numbers. So let's find the standard form of a complex number. The standard form is written something like this: z is equal a plus bi, and a and b are real numbers, and I is called imaginary number. So let's write the standard form again. We have z is equal a plus bi, so those here both are real numbers, and this here is imaginary number. And same thing, we have this part. For example, we have here z is equal to a plus bi. This here we call it the real part, and this here we call it the imaginary part because it includes I. However, even this is not always you can find the complex number is in this form. Sometimes you might find it something like this. For example, z is equal 3. It's still a complex number, but just b is equal to 0. Or sometimes you find z is equal minus 2i. It's still a complex number, just a is equal to 0. So let's see when we have something like this. z1 is equal to, for example, a plus bi, and z2 is equal to c plus di, and we have z1 is equal to z2. Therefore a is equal to c and b is equal to d. So let's talk the value of the power of I. We already know that I squared is equal -1, and I to the power 1 is just I. So let's see what is the values of the power of I. So we have I is equal to I to the first is equal to I, and I squared is equal -1. I to the third is just I squared multiply in I is going to give us -1 multiply in I is just minus I, and I to the fourth is equal to, is just I square multiplied in I square is equal to minus 1 multiplied in minus 1 is just 1, and I to the fifth is equal to I to the fourth multiplied in I is equal to I, and I to the sixth is just equal to I square multiplying I square multiplying I square is equal to minus 1 multiply in minus 1 multiply in minus 1 is just give us minus 1. So if we see from here, if we observe that the number just repeating around in between 1, negative 1, I and negative I, the only values that I could have. Now doesn't matter which power is. So let's figure something. Maybe we have a relationship here. So we have here 1 and negative 1, I, negative I, 1, negative 1, I, negative I. We see the repeat each 4 times. So what we're going to concentrate in the power and divide it by 4. So for example, we have I to the 18. So what we're going to do, just divide this by 4. How much is going to give us? 6 is going to give us 4. 4 and 4 is 4, and the remainder is 2. So this is equal to I to the second is equal to minus 1. If we find I to the 21st, for I to the 21st, for example, I to the 21st is equal to what? Divided by 5 here, and the remainder is 1. So I is equal to I1, I to the first is just I. So this is the formula. If we have I is to the power, just divide it by 4, and the remainder between 1, 2, 3 and 4, it will be the same answer, whatever remainder here. If we have 1 is equal to I1, if we have remainder 2 is equal to I square, if we have 3 is equal to I to the third, if we have 4 is equal to I to the fourth. Let's do another example. If we have I to the 12 is just equal to I, and if we divide 4 by 12 by 4 is just 3, and the remainder is 0. So this is I to the 0 is just 1. All numbers equal to 0, the power 0 is just. So now we are going to talk about addition, how we can add two complex numbers together. It's very easy like other numbers. So we have, for example, z1 is equal a plus bi, and z2 is equal c plus di. So z1 plus z2 is just a plus c plus b plus di. What we do, we just we sum those numbers here together, and we sum those here together. We sum the real numbers together and the real part together, and we sum the imaginary part together. So let's do some examples. For example, we have z1 is equal 4 minus 5i, and z2 is equal to 1 plus 3i. So z1 plus z2 is just equal to, we see here we have the real part here and we have the imaginary part here. So what is going to be is just 4 equal to plus 1 plus minus 5 plus 3i. So this is going to give us 5 minus 2i. So this is the solution for this sum. So let's do another one. It's very simple. This is just forward. You don't have to do anything, just you put the real parts and you put the imaginary part together. So let's try another example. We have z1 is equal to any number minus 4i, and z2 is equal to minus 7 plus 29i. So z1 plus z2 is equal to minus 7 plus minus 7, 3, I want to say 3 plus minus 7 plus 4 plus 29i. What is going to give us is just minus 10 plus 33i. So this is the other solution. It's very simple. It's just very easy. So let's see how we can multiply two complex numbers. So we have, for example, we have a plus bi times c plus di. Multiplication is like we're doing the distribution. It's just you multiply, same thing, this in this one here, then you multiply this in this, this and this one here, we multiply this in this one here plus this one here, and you multiply plus this one here, and you multiply this here. So what is going to give us in this case is going to give us AC plus ADI plus BCI plus BDI square. So what is going to give us is going to give us AC plus ADI plus BCI plus minus this I square here is just give us negative 1, so will be minus BD. So the answer for this one here is going to be IC plus minus BD plus AD plus BCI, and this is a relationship is always is true. If we have any number, for example, let's try in another number, another two numbers. We have 3 plus 2i times minus 2 minus 5i. So what's it going to give us? We say just is equal to IC. We take we have A here and we have C here. This is IC. So what is going to be minus 6 and minus BD. B is 2 and this is negative 5. So will be minus 10, because minus negative 5 multiplied into is minus 10 plus AD. We have A here and we have A, B, C, D, and we have D here. So what is going to be minus 15? Minus 15 plus BC. We have B here and we have C here is minus 4. Minus 4i. So what is going to give us? Very simple, easy to go. Minus 6 plus 10 is just 4 plus negative 15 plus minus 4 is just negative 19. So we take this plus here, we put negative 1 time, negative 19i. So this is the solution. Can use the form or we can do it straight, just do distribution. So let's find another problem. We have 7 plus 3i times minus 1 plus 6i. So what is going to give us just AC A minus 1 is minus 7 minus BD. B is 3 and D is 6 is 18, and we have minus is minus 18 plus we have AD, we have A is 7 and D is 6 is 42 plus BC is just 3 multiplied in negative 1 is just negative 3I. So what is going to give us here? Minus 25 plus 42 minus 3 is just 39I. So this is the other solution here. So it's very easy just to distribute. If not, you can always use this formula here, and you know that A is the first letter and so on. A conjugate. What is a conjugate of a complex number and what is used for? So we have, for example, Z is equal to A plus BI, and the conjugate is going to be Z. We always put this line on the top of it. This means conjugate. When you see it, the difference is just that line, and this called conjugate is just always to A minus BI. So therefore you see just A is still the same, just imaginary number, imaginary part, we always change the sign. If we have negative, if we have positive, we make it negative, and if we have negative here, we make it positive here, just to change the sign. For example, if we have, for example, C is equal to 3 minus 5I, therefore conjugate is equal to 3 plus 5I. That's it. It's very simple, just to change the letter. If we have, for example, something like this, Z is equal 3, the conjugate is going to be 3 because it's still the same number. And if we have, for example, Z is equal 3I, so the conjugate is going just to be negative 3I. Just to switch the last part, because here in this case, for example, we now is just is same thing, just A is equal to 0, and this here is just B is equal to 0. If we change the sign of 0, it's still 0, doesn't change anything. So let's see what is useful for. Sometimes we have something has a complex number in the denominator. For example, let's write a complex number has a complex number and the denominator. For example, we have 3 plus 2I over 1 minus 6I. So always we don't like to leave like the imaginary number like this in the bottom. We like it to be a real number, because this I is unknown, so how you are going to divide for something you don't even know how much. So what are going to do? So in this case, what we do, we multiply by the conjugate. So in this case, what is going to give us here? So what we do, we multiply both parts. So what is going to give us here? 3 plus 2I over 1 minus 6I. So multiply both parts with the conjugate. So the conjugate for this one here, for this number, is just 1 plus 6I. This is the conjugate. So we multiply both parts in the conjugate. So what is going to be, multiply in 1 plus 6I and multiply here 1 plus 6I. So what is going to give us here is equal to what? You multiply 3 in 1 is just 3, and plus 6, 18i plus 18 plus 18i, and multiply 2i in 1 is just plus 2i, and multiply 2i multiply in I is I square is negative, and 2 in 12 is 12, just negative 12 over what? Let's go here, is going to give us multiply 1 in 1 just 1, multiply 1 in 6i just 6i, and minus 6i, and plus 36, because negative here is negative 36, and I multiplying I is just negative 1 and change positive. So the answer for this here is going to be minus 9 plus 20i. We see here is this, and this is 9, and this is 20 over 37, because this here is going to go out, it will be cancelled. So we see we have here, let's write another color so it looks nice and shiny. It will be minus 9 plus 20i over 36. So we see we don't have I anymore, we take it off, we just have another two numbers. So this is the way how we can use the conjugate. So let's plot some complex numbers. So let's put something like this, and we'll try to plot some complex number. For example, we have here z is equal to 3 plus 5i. So the real number is just, it will be here in x, and imaginary number part, it will be in y. So here it will be just 1 2 3, and we have y is 5, 1 2 3 4 and 5. So here, so this is here, it will be the z, and let's do another, it will be z here, and this here is called r, and r we call it modulus, and this angle here is theta, and we call it argument. So why, if we go back to, if we see this here is x, and this is here is y, so in this case here this is a, and this is b. So therefore, so a is equal r, if this is a here, r cosine theta, and b is equal to r sine theta. So if we go back to the equation, we can write z bi, and it will be just equal to r cosine theta plus r sine theta I. So it's going to be just like this, z is equal to r cosine theta plus r sine theta I. This is how you can write a complex number, and equal to a plus bi. So this is equal. So let's plot another number. It's very straightforward to do it. So what we have, we can do, we have z is equal to minus 2 minus 6i. So we say then the first number just in x we have negative 1, negative 2, and we have negative 6. 1, 2, 3, 4, 5, 6. This is negative 6. So the point is going just to be here. This is here, that's for this point is here. This is z. So it's very easy to plot like you are plotting the real numbers. And that's it. And subscribe and share, so help me to put more videos and give me more energy to enjoy what I am doing, and I will do it right and provide you whatever you ask for. You can leave comments, or if you have any problem ideas, just write in comments. I will be glad to answer all your questions, and thank you for watching. Take care.